population proportions. Uh, it's very easy to identify because bottom line is you have percentages from two distinct groups. So when we were working with the Apple question, it was a percentage and it was only one group, right? You had one set of successes and one set of trials. Now we're just going to have two, all right? So the variation comes in the form of the null and alternative hypotheses, but pretty much everything else is the same, right? So here, what we're doing is we're comparing proportions to one another, all right? Not comparing them to a particular value, because what I'm trying to say is that maybe the population proportion from one group is more than another group or less than another group, or maybe just simply not equal to another group. Right? So if I want to talk about a disparity between two groups, this might be how I do it. One semester I did this I was teaching two different stat classes, and I perceived a disparity between the passing percentages from one group to another. So what I did was I counted the number of students who passed a particular test from one group out of the total number of students who took the test, and I counted the number of students who passed the test from the other group, same deal, and then I ran this analysis to see if there was statistically enough evidence to say that there was a difference between the two groups. All right? Now, why I would do that is the more important reason, or why I'm really discussing this, because I already know which group performed better. You have a simple percentage. You had 15 out of 20 passed in one group, and you had 12 out of 18, something like that passed in the other group. All right. So you had a difference between the two groups that you could quantify. So I already know which group performed better. Now there also are little variables in there like, well, what's better? You could have an entire class that passes a test, all with D's. Or you could have a class where 14 out of 20 of the students passed the test, but every one of those 14 students got A's. So it's feast or famine. The other students got F's, but clearly something went really, really right with the A students. So if we could just tap into what made that happen and make it happen for more people, or at least explain why the F's occurred, maybe they just blew off the test. It could be something as simple as that. Or, I've been trying to, like when I first started teaching, which is why I do the podium. When I first started teaching, I would be at the board and I would find myself, and an administrator, a really nice administrator whose opinion I respected, would say, as I was teaching, like he would observe, and then afterwards he would say, "Do you like your students?" And I was like, yeah, sure. I mean, I'm human, so some of them probably not. But, like most of it, yeah, good chunk of them. He's like, so why are you avoiding eye contact with them? And I was like, well, I didn't really realize I was doing that. And he said, yeah, because what you're doing is you're looking at what you're doing on the board, more focused on that, and you're not really looking around and making eye contact with people. Now, I also remember as a student, every time the teacher would look at me, I'd be like, stop looking at me, freaking weirdo. So, like, I try to, like, if I glance at you and make eye contact, I try to move on pretty quickly so that you're not like, why do you keep looking at me? But I am trying to get a sense of engagement. Like, are you with me? Are you getting it, So, but it wasn't always like that. So maybe when you have 14 out of 20 students getting A's and the rest getting F's, maybe there's some people that were just kind of left in the dust. Like maybe they didn't get the attention that they needed. Maybe it was something that was happening on the teacher's end that could have been accounted for that the teacher is oblivious to. These are some things that come into play. So that's the motivation for why I would do something like that. All right. So my interaction between one class and another. All right. So one class was a little bit more hands-on, and another class was a little bit more lecture style. All right. It could be time of day. Like this is a morning class. Oftentimes, not this semester, but oftentimes I teach a stat class at night during the week. All right. So if there's a disparity between performance, it could be time of day. It could be the fact that you got to sit through a 4-hour lecture that one time that you have stat on a weekly basis, and they have to sit through hour and a half, 2 hours twice a week. What are the differences between those two classes? That's the motivation behind it. All right. But when I wrote this question, I was more concerned about football than I was about teaching. So that's probably not something I should have admitted. But I was very, very concerned about football because I thought at this point in time, I was thinking about changing my career because I had an administrator, not the one who gave me the good advice, but another one who is, I'll explain this when I'm not recording later, but this individual is on my list. All right, I'll explain what that means. But it's not as terrible as it might seem at first glance. It's bad, but it's not terrible. I don't think there's a way to pause the recording, so I can't. I'll just do it later. But yeah, I because of that interaction, I seriously considered going into statistics in athletics, football or something, so I started looking into stuff like this, realized it was way harder than I thought, and I was like, all right, fine, I'll still be a teacher. All right, then I grew to love it once that person was out of my life. So anyway, study was conducted to determine if the ratio of passing touchdowns to passes attempted by Peyton Manning has increased. I never changed the tense. Had increased. It was a long time ago now. Between the years of 2003 and 2004. In 2003, Manning attempted this number of passes with this number of touchdowns. In 2004, he attempted fewer passes with more touchdowns. Using a .05 significance level, Tesla claimed that the population proportion of touchdown passes has significantly increased between the years of 2003 and 2004. All right, so what I was trying to do was not really determine whether Manning's percentages changed significantly, even though that's what the question seems to imply. I was looking to see if there was something that significantly changed in the NFL that allowed for this to occur. Right? So I was trying to project it out into the population using Manning as a benchmark for that population. Right? Thinking that, all right, you went from 29 touchdown passes to 49 touchdown passes with less attempts. All right? So a lot more successes with less trials. So I look at it like you're playing roulette or any kind of game of chance, and you win a certain number of times. Let's say you win 5 times in 30 trials. All right? But then the next time you play, you win 20 times in 25 trials. All right? So you went from 5 in 30 to 20 out of 25. A massive change. Are you thinking that the game is fair at that point? Like, or are you thinking that something happened behind the scenes to allow for this to occur? All right? Did something, was it a different die involved? Was it, the rules, a rule change to make it easier to win? Like, what are the possibilities? So around this period of time, context, whether you care about it or not, I mean, it is context and it's valuable. There was a rule change in the NFL. All right? It involved the defense. So defense couldn't do certain things in the past that they were able to do, right? Which allowed more freedom for the offense, right? And I'm looking at this and saying, okay, that's what did it. The player was a good player, like a very good player prior to this rule change, but then he became like otherworldly, all right? So that's the motivation behind the study. So now you take this idea and you say, okay, I don't care about football, but I care about movie production. Right, the amount of gross income related to the budget of a movie. All right, and compared over a period of 2 years, 10 years, whatever it is. All right, low budget versus high budget. You can really kind of play around with this idea and do a lot of different things with it. It does not necessarily have to be stuck in the world of sports, as a lot of statistics scenarios might make it seem. But anyway, so I have all this information, and it's like, whoa, I got a lot of stuff going on here. So let me slow it down and itemize it. I have 2 years that I care about: 2003 and 2004. In 2003, we had a certain number of trials that we'll call N. That was equal to 566. 29 of which were successes. All right, and that's the thing you got to understand, that touchdowns, passes, whatever, it's trials and successes. All right, so when you're thinking about your project, don't think, well, it's got to be football. Trials and successes. All right, number of people who ran a red light versus the number of people who passed through the intersection. All right, trials would be the number of people who passed through the intersection. The number of people who ran the red light, that would be the number of successes in that situation. Right, this stop sign right here, I've been begging students for the last 15 years for somebody to do a study on that. All you have to do is pretty much what I did in the last problem. Set up a lawn chair, go out there. You don't need a stopwatch or anything. You just observe. Have a little clipboard, use your phone, whatever. All you're going to do is, and this is for the individuals coming in, all right? Because there is no stop sign there if you're coming in. People are either going to recognize that there's no stop sign and do what they're supposed to do, or they're going to stop. So stay there for 20 minutes, half an hour, whatever. All right? Pick the warmest time of day. Set up your lawn chair. All right? That car did not stop. 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 However many cars come through. Just it's a question of who is following the rules, who's doing the right thing, right? Because the other way is a little too hard to quantify. Like the people who are at the stop signs, the intersections, and then you have the T coming in. Yeah, the other ones. I mean, there have been plenty of situations where a person's at that stop sign and they're like, yeah, I've waited long enough, I'm going. And then they almost cause an accident. But I think that's that's few and far between. The people who screw up that intersection are doing it when they're coming in. And then the people that are at the stop signs are making decisions based off of the screw up there. Because when that person stops, then the person adjacent to them is like, well, I guess I'll go. And then they try to go, and then that person goes, and then there you have it. Then I get the email during the day saying that there's been an accident again, and so it is what it is. But
personal thing is supposed to be a stop sign where we enter that intersection to talk.
yeah,
Usually the stop signs are in the like short turns.
right.
In a straight street, like mostly it doesn't happen. But every time I come, I stop just in case. Lately, I realized that there is no stop sign. I stop because I'm like, just in case somebody decides to
Right.
go.
Because if you're not expecting it, you would think that there is a stop sign there.
It's supposed to be the third stop sign, in my opinion, because just for the sake of safety.
Right. And so maybe a study that we conduct could cause some change here. I know why they don't put a stop sign there, or why they didn't do it, is because they don't want traffic backed up out into to the road. But what I do, honestly, and it sucks, every time I go through that intersection, I have one hand on the horn. Like every single time I'm going through, I'm like, don't do it, don't do it, don't do it, don't do it, don't do it. Okay, there we go. And so, I mean, I've had to give the salute a couple of times. Like as I've gone through the intersection and somebody's like giving me a dirty look, I'm like, I don't have a stop sign. There's something for you. Take that home with you.
Tell them do not take my flag, otherwise.
Yeah. Yeah, I look them right in the eye. I'm like, you one of mine? No? All right. But I'll have people tailgating me into the campus, and I'm like, I'm looking in the rearview mirror. You better not be one of my students. Better not be, because you're like, you have 100 average, and you're still not passing my class. So in 2004, Manning attempted 497 passes, and 49 of them were touchdowns. So, the little question here of, well, we got two N's and two X's. Well, which one's which? Well, one came before the other, so I'm going to subscript the first one with a little 1, and the second one I'll subscript with a 2. It really doesn't matter which one you sub with a 1 and which one you sub with a 2, as long as you're consistent in how you use that information from here on out. All right? But generally, it's a pretty good rule of thumb. The information you write down first gets subbed with a 1, and the information you write down second gets subbed with a 2. All right? We got a 0.05. Alpha's 0.05. It says, test the claim that the population proportion of touchdown passes has significantly increased between the years of 2003 and 2004. All right. So we have two population proportions. So I'll abbreviate a little bit. Two population proportions. All right, because it's saying population proportion between the years of 03 and 04. Those are 2 years. All right, so that gives you a clue as to what test you're working with. All right, so we know it's a 2-prop z-test. All right, z-test, t-test, it doesn't matter. 2-prop is the key. That's what we're looking for. The prop being proportions. All right, so now that we know what kind of test to work with, it's a question of, okay, let's find it in the calculator. So stat, test, option 6, 2-prop z-test. We could write our null and alternative if we want before, simultaneously, really doesn't matter, but sometimes, I mean, just for the satisfaction of knowing you're on the right track, I've seen people, they like to do the calculator stuff first, make sure that they selected the appropriate function based off the information that they have. Now this one, this is beautiful. You know, they're not all as clean as this particular hypothesis test, but you look at what we wrote down on paper and what it's asking us for, and it's like, dang, really can't screw this up. That being said, half of the people who attempt this problem screw it up, right? And that's because we just wrote down the n and the x in that order. For whatever reason, that's going to correspond to this. People are going to write x1 as 566 and n1 as 29. You're going to get it backwards. All right. X always has to be smaller than n, right? Because x is the part, n is the whole. All right. So hopefully by me bringing this up, the most common errors, maybe we can avoid those. All right. But you can see here we also have an alternative that we have to account for. So that's where we kind of get into the nitty-gritty of it. And so I'm going to make a statement that there is a relationship, and I'll write HA. I'll write the HA first. And that's P1 has a relationship to P2. All right, my first and second population proportions are related to one another. All right, this is the part that can be a little tricky, and just because of the language. It says significantly increased. All right, most of the time we incorporate increase with more than, greater than, so you might just jump right to putting a greater than symbol in there. It's actually going to be a less than symbol. All right, less than shows an increase. All right, and that's because the earlier value is smaller than the later value. All right, so the best explanation I can come up with, it's not the most mathematical. Stick figures. All right, increase, right? There's an increase in height, but if you look at the size, right? So we have the size of the first individual and the size of the second individual. Now there is an increase in height. But the first individual is definitely smaller than the second individual, so a less than symbol. All right. So that's what we're talking about in the alternative. We're talking about the size of the proportion. So an increase is showing that the size before is less than the size after. All right. Now the null, same ingredients. So this is the habit that we're forming, and the familiarity of it is going to allow us to kind of really just take this for granted. Same thing, just with an equal sign. I was about to write H for some reason. All right, so that is our default. If I can't say that there's been an increase, then all I could say is that, okay, I guess they're the same. All right, I can't say necessarily that it's gone down, so I just default to, okay, all things are equal. I give up. That's what the equal sign means. I give up. I forget it. All right, so 29, so I'm typing in the 29, the 566. The 49, the 497 in those orders, and then I want to select a less than symbol. And then we go to calculate. And again, all we're pulling out of this is the p-value. And you see, it gives us a lot more information, but again, there's only so much I care about. Now, it's my understanding that in most cases, I haven't researched every program, but in most cases, the requirement is 1 semester of college level statistics. So not many folks go on to take follow-up courses in statistics. If you were to do that though, you would learn what all these other values are all about. But for our purposes and the purposes of you being able to, because again, that's my theme for the course, is that you can take what we're learning in this class and apply it directly in the real world the minute you walk out of here. The p-value allows you to do that. All right. So I was focused on football. You could be focused on sizes of clothing. All right. That's a good example because I was at Marshall's yesterday, and I found what I was looking for. I wanted 2 Columbia fleece sweaters, zip-ups, size 2X, and I actually found them, but it took a while. But dang, there was like 700 extra smalls. And it's like, all right, so I think there's a significant difference in sizes. So like I would start looking at that as like, okay, is it beneficial for me to even go into the store if they're not going to have the sizes that I'm looking for? Right? Where do these sizes come from? And it turns out that they use statistics to determine how many of each size to produce when they're creating clothing. So that's why when you go in the clearance section, you could see people that they could get their whole wardrobe out of the clearance section because extra small, wonderful, that's me. And then there's me that's like, oh, extra large. Oh, that sucks. Okay, I guess a lot of people are like that. So, but the p-value, we could apply that immediately. All right, the z statistic and stuff like that, you can, but it's more work.
When you're highlighting, you're just highlighting the key, right?
I'm trying to, yeah, but that's the idea.
Thank you.
No problem. So the p-value is less than alpha. All right, so I'm streamlining a little bit here because before I would actually ask the question, is p-value less than alpha? And then we'd look at the numbers and compare them. But the bottom line is, somewhere on paper you have the alpha. In your calculator you have the p-value. I just need to know what the relationship is between the p-value and the alpha value. All right? So you should also state what the p-value is, but you don't have to write the inequality where you state that 0.001567 blah 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 is less than 0.05. All right. So the p-value is less than alpha, therefore we can reject the null hypothesis. All right, so null hypothesis is it's a no-go, which means the alternative hypothesis is where it's at, and so I can draw my conclusion now. And again, that conclusion, because the language of statistics is often a lot more implied than it is explicit. So when we write the conclusion, it makes it seem an awful lot like we're just talking about Peyton Manning, which makes it seem further like, oh, why? We already knew this information. We're looking at Peyton Manning as being an exemplar of quarterbacks in the NFL. Right? So he is an example. He is a prime example of quarterbacks in the NFL. So if we want to draw a conclusion about all quarterbacks in the NFL over these periods of time, we could use his information as a benchmark. Right? So by comparing his information over 2 years, we can then project that out to all quarterbacks. All right? Maybe you disagree and think, well, Peyton Manning was not a good example. Maybe it's somebody else. You know, maybe he's not even a quarterback. It's a different position. You know, like you could do anything you want with it. But that's why I keep saying that statistics, it's a pliable, malleable concept. All right? It's the kind of thing that like you could bend to your own will, and so two people could have the same data sets and draw the exact opposite conclusions. Right? So it all depends on how they look at the data. So now what I need to do is just write that conclusion, and I don't feel like I've pasted anything in a while, so I'm going to give it a go. Oh yeah, look at that. So we're just going to annotate this. So the first line is going to be all the black stuff exactly the same, because we are rejecting the null. I don't even have to adjust that. There is sufficient evidence to reject the claim that the now we state the null hypothesis in words. And of course it does not involve apples in any way, shape, or form. So abbreviations are going to be crucial here. Otherwise, you're going to just go insane writing these conclusions. So population proportion of TD passes.
So this time it's sufficient, right?
Yeah, it's sufficient, yeah. Is the same between 2003 and 2004. At the 0.05 significance level. All right, so that I think did a fairly good job of addressing the null hypothesis, because the null was saying that P1 equals P2. All right, P1 is the population proportion of touchdown passes in 2003. P2 is the same thing in 2004. So I could have written the claim that the population proportion of touchdown passes in 2003 is equal to the population proportion of touchdown passes in 2004. But I've gotten writer's cramp just thinking about that. So I don't want to do that. So you streamline it a little bit. Therefore, the claim, now we know what it is all about. So the claim of an increase because we know what we're referencing here with the of. The claim of an increase is true. All right, so you're kind of you're developing a little bit of flexibility within the template, right? To save yourself some time and energy. So there's sufficient evidence and sufficient corresponds with truth to reject the claim that the null hypothesis, population proportion of touchdown passes, is the same and equal, mean the same thing, between 03 and 04 at the 0.05 significance level. That didn't change. Therefore, the claim.
Oh, that.
Yeah, okay, so grammar, I
I
guess
got
that's
one from there.
the claim of an increase is true. I gotta get rid of that part.
Oh, that increase or increase?
Of an increase. I'm gonna kill the that.
I'm not trying to correct you, I'm trying to learn my English.
I'm trying to do the same thing, so we're on the same page. I think. Actually, you're probably a few pages ahead of me. Got a nice winning streak going on Duolingo though.
Oh, did you try it?
Yeah, I did one. I set it to 5 minutes. So I try to start off slow, but I did a little bit this morning. You know, sometimes it gives me the alert at the wrong time, but I figured I'd learn some Spanish, and then after that I'll learn Klingon. Yeah, apparently that's an option. I had no idea. So that's pretty cool. Not as many people know what Klingon is anymore.